would like to introduce Dr. Steve Kilston, astronomer and retired aerospace engineer, for tonight's Science Pub presentation, Grokking, the 2017 Total Solar Eclipse. Starting with discovering a comet at age 21, Dr. Kilston has applied astronomy in academic research and teaching, planetarium and public lectures, radio programs, and national and international aerospace projects. At Hughes, Lockheed, and Ball Aerospace, he designed and promoted space-based telescopes, including Iconos, the high-resolution commercial Earth imaging camera, which made possible many new technologies, including Google Maps and GPS automobile navigation systems. It was called one of the most significant developments in the history of the space age by the New York Times. Dr. Kilston also earned his BA from Harvard and PhD from UCLA. During his studies at Harvard, he had the chance to write his thesis, A Search for Intelligent Life on Earth, under Carl Sagan. And about the presentation tonight, on August 21st, 2017, the moon's shadow shall darken a path across the country from the Pacific to the Atlantic, including right across Oregon. More Americans will view this solar eclipse than any other in history. This presentation will discuss how eclipses happen, how to get the most of your Oregon experience, how eclipses and the sun relate to our human future, how eclipses and astronomy can help us feel our universe, and Dr. Kilston will also explore a few unusual connections of eclipses. And with that, we welcome our speaker. Thank you.
Thank you all very much for having me here. I've usually been sitting on that side of the room. And when we take the trivia questions, I'm sorry? When we have the trivia questions, I usually get 3 or 4 right, so don't feel too bad if that's all you got this time. I want you to understand what I'm saying, not just to hear it. And if you don't understand what I'm saying, that's entirely my fault and not your fault. So make sure that you ask questions at the end if there's something that I really goofed up on explaining clearly, okay? I'm going to explain near the end of the talk what I mean by grokking, if those of you who haven't heard that term. But let's get into what we have right now. Oh, you had one? I see. Okay, good. Okay, you've heard what the topics are. We'll go past that. Okay, this is a very important chart, so pay close attention to this one, please. You all need to know what new moon is and full moon and what a lunar eclipse is and a solar eclipse, okay? You can probably see clearly on the chart that in one of these, the moon is between the Earth and the sun, and in the other one, the sun and the the sun and the moon are on opposite sides, and the Earth is in between. All right, take a look at this a second. You can see that the dark side of the Earth is always the side away from the sun. Does that make sense? Okay. And the dark side of the moon is always the one on the opposite side of the sun, right? Because the sun is what's lighting them up. All right, and then you also can see that when the Earth is at night, you can see the moon, and it's a full moon case because you can see the moon being lit up by the sun, right? But if the moon is towards this way, you're looking at the dark side of the moon from the Earth, and you're not seeing much of a moon. That's called a new moon. Those of you old enough to remember Ed Sullivan on television may remember that he used to say that we're going to have a really big show tonight, and he meant show. So when you think of the new moon, think of no moon, okay? It's the same kind of thing. All right, so when we have an eclipse, it's exactly lined up. It's not always exactly lined up. That's what that thing about the 5-degree tilt was all about. If you have a tilted orbit, then some of the times it's not going to be in line with you. It's going to be too low or too high, and that's when you don't have it lined up. All right, there are 2 parts to the shadows involved here. Is this making too much of a echo? It's all right? Okay, the shadows form a dark shadow that's entirely making the sun invisible there. And they also have a partial shadow. The partial shadow is called the penumbra. You can see part of the sun when you're in that position. And if you're in the umbra, the center of it, the dark shadow, you see none of the sun. Now, this is, of course, a two-dimensional diagram on the screen. It actually all occurs in 3 dimensions. So what the sun does when it hits the moon here at the bottom, it makes a cone, like an ice cream cone in shape, and that tip of the cone on the right side hits the Earth, okay? Now, if it doesn't hit the Earth, if this moon is a little farther away, which it is most of the time, that shadow will not touch the Earth, and you won't have a total eclipse at all. You'll have what's called an annular eclipse. It'll be like a ring around the moon. But in the maybe less than half the time that the moon is closer to the Earth, then you have a chance for a total eclipse because the cone will touch the Earth, and there'll be a spot on the Earth that is where the total eclipse can be seen. Is that pretty clear to people? I'm sorry, speak. Oh, so it's the microphone. Ah, thank you. I was wondering about that. Okay. Is it, can you hear me better here? How about here? All right. Yeah, the boom is probably my breath coming out. Is that better now? All right, let's keep it down here. I thought there was something wrong there. All right. Can you hear me now? Okay. What you're seeing here is a picture from space of the Earth showing the actual shadow of the moon during an eclipse on the Earth. That's an actual picture of a solar eclipse, and it's quite dark there. This is the path that we're going to have on October 21st for the eclipse that goes across the whole United States. They're calling this the Great American Eclipse because it's covering the whole United States across there. And I'll show you how that works. Now, what you're seeing, of course, is nighttime fading away on the left and the moon's shadow going across. That's actually a simulation of the moon's shadow. And in the center of that, do you all see a black dot? That black dot is the only place where there's a total solar eclipse. Only in the black dot is the sun entirely blocked for a little while. It goes pretty fast. And as you'll notice, when it starts off on the left and when it finishes on the right, it goes faster. And that's because of the curvature of the Earth. It's covering a lot more miles as it's going along a slope that way. Here it's going to speed up at the end. And it's when it starts again, it goes pretty fast and then slows down going across the Earth. Okay? Do you all see that? Okay. There's a different speed on the ground depending on whether you're right underneath where the eclipse is in the center or whether you're sort of at the sunrise or sunset. Now, can you all tell me what the fuzzy large shadow is called? The penumbra, and where the dark shadow is called the umbra, okay? Just meaning dark. Now, we're very lucky because of that 5-degree tilt, as I say. The sun and the moon and the Earth are not always lined up. But only when the moon, with its tilt, crosses the Earth's orbit, projected into space. That's called the ecliptic. How we see the sun in the sky and the Earth's orbit, that's a plane, which is called the ecliptic plane. And maybe it's called that because eclipses can occur there, right? The word eclipse comes from ancient Greek, and it has to do with sort of being left out, or abandoned, or something is gone when the moon or the sun, when the moon or the Earth are eclipsed, something is gone. Moon or the sun, sorry. All right, so I'm not going to cover everything here. It does say about the 375 years. That's the average between total solar eclipses in any one place. They go in lots of different places. That's why they're happening more often if you can travel. And we're not going to have a total solar eclipse right here in Cottage Grove this year. You know that? Okay, because we're not quite in the right place. They will have one in Corvallis and Salem and a few other places. The path of the eclipse, that is, that little black spot that I showed you going around, is 62 miles wide. You have to be in that 62-mile wide strip in order to see it here in Oregon. About 800,000 people in Oregon are in that path. Now, how many of you are afraid to go into that path because it's going to be too crowded? I recommend you do it anyway. I think you will survive, and it's worth the trip. Pardon? Yes. Yes? Where am I going to be? I'm not sure yet, actually. Okay. The next total solar eclipse in the United States will be in 2024, and mostly in the southeast part of the United States. And the next one in Oregon will be in 2108, as it said in the quiz, and July 25th, which is exactly today, right? All you have to wait is another 152 years, and you'll have one from today. You'll have another one here. Now, this is another picture of the same path across the United States, but the important thing about this picture is it shows what the expected cloud cover might be. And where it's blue, it's good. That means there are a few clouds. It's blue sky mostly. And where it's sort of reddish or brown or green, you have a much worse chance of seeing the eclipse because they tend to get a lot of clouds that time of year. So we're in a good state here to be seeing the eclipse. It's mostly clear here.
Yeah, we're going to have 80 million visitors.
All right, I showed you on the animation how the eclipse goes pretty fast across the world, and I just wanted to say here that its average speed across the United States is about 1,600 miles an hour. You're not going to keep up with it, but in Oregon it's even faster. And because it's going that fast, the little spot you see goes by you, and no place in the world for this eclipse is it going to last longer than 160 seconds of total eclipse. It's a short amount of time. Now, why is the speed so fast? It's because of two things. It's because of the moon having a speed of almost 2,300 miles an hour in its orbit. That takes a whole month to go around the Earth at its distance, but that's the speed of the moon. That's not how fast we see the eclipse go everywhere, though, because the Earth is going in the same direction at the equator, spinning over 1,000 miles an hour, and we have to subtract those two speeds to see the net speed of the moon during the eclipse of the shadow going around. Okay, and as I say, the highest speed in Oregon when it starts off on the coast is going to be 2,400 miles an hour, slowing down to 2,100 miles an hour when you get to Idaho. Here's a picture of what the spot will look like in Oregon. It's going to travel along that stripe, and it's going to have about that shape. The shape is oblong because of the fact that the moon is going to be, and the sun, both are going to be up at about that high in the sky. It's only 10 o'clock in the morning, so you don't expect the sun to be overhead at 10 in the morning. It's going to be there, and so we're seeing it at a great slant, and that slant projects the shadow to be elongated, right? Okay, about 90 miles east-west and 62 miles north-south. Even when the moon is closest to the Earth, which for this eclipse it isn't, even when it's that close and the spot is biggest, you never have more than 7 minutes for an eclipse, the bigger spot. Okay, what we expect to experience is it's going to get dark, okay? You know that's true. And the air temperature is going to drop noticeably. You're going to see it getting quite cool during the eclipse, even though it's going to be August, where it's normally hot. I'm not going to say too much about all these things. You can ask later if you want. I just wanted to say that the corona, which is the main thing that makes total eclipses really fantastic, is that you never get to see the corona at all except during a total eclipse of the sun. Okay? And that's when the moon blocks out the bright sun and you can see this huge halo around it. That corona is well over 1 million degrees in temperature. It's very, very hot because it gets heated from below by the magnetic fields of the sun primarily. And that might be a spectacular thing that you see. Bailey's beads, which we mentioned, I'll show you a picture of that. Oops, I have to go back one. There we go. Bailey's beads are pretty nice, bright things. People used to think that these were things on the sun, but now we know they're not due to the sun itself. They're due to the fact that the moon's edge is not perfectly smooth. The moon has lots of mountains and craters and things like that. And when they barely cover most of the sun, but there's a little valley or crater or something like that, we can see the sun through that, and that makes a lot of extra concentration of the light around the edge of the sun. All right. So here's sort of the whole thing. You might get to see something like this. You might get to see this. The corona streamers coming out along magnetic fields lines from the sun. Sometimes, and I don't expect it too much now because this is not a time of high sunspot activity on the sun, but sometimes there are huge arcs of gas that can extend out almost half the diameter of the sun from it. Those are called prominences. But you may see a rather spectacular sun. And when you look at the sun during the eclipse, when it's in totality, for that 2 minutes it's going to be in totality in Oregon, you can look right at the sun without any special eyeglasses or anything like that because it's covered by the moon. It's safe, okay? Is it safe to look at the sun when you put your hand up blocking it? Yes. When you block the sun with your hand, it's safe to look up at the sun. If you put your eyes in the shadow, and that's the same thing that the moon does, okay? So don't be afraid of the sun when the moon is entirely covering it. But be careful, because it's not going to last long, and you don't want to keep looking when the sun comes out from, or when the moon goes past the sun. Yes? Okay, I'll talk about that in a minute. When it's the total eclipse, guess what? Not only does it get dark and cool, but there's all sorts of other things that happen. Birds go to sleep, insects might come out, you might get some mosquitoes coming out or something. And then when the sun reappears, the morning birds will come out. They'll think it's actually morning, okay? You're going to have, this is one of the things I can't emphasize strongly enough. Rather than being in a city, if you can be somewhere near the woods or nature or something like that, you'll have a better eclipse experience because you can't depend on people to do anything, but you can depend on animals to do things, okay? All right. This is what the sun's going to look like. It's going to be in the constellation of Leo. It's going to be between Mars and Mercury. Those planets will be visible. The star Regulus in Leo will be, that's the brightest star in Leo, will be right next to the sun. And if you look at a bigger picture, again, this is going to be in the east. You want to have a good view to the east, wherever you are in the morning. That's where the sun is. But the covered up sun in the east, if you go further toward the south or the west, you'll see all these constellations, okay? And particularly, you'll see the bright planet Venus. That'll be very obvious. You'll see the constellation of Orion and Canis Major with Sirius. So there are going to be quite a few bright stars there. And this is, how do I know this? Any idea? Because people have been mapping the skies for thousands of years, and they've been mapping the eclipses for a long time, so we really know these things very exactly. You can get a lot of this information thanks to your tax dollars that support the United States Navy, and the Navy has a nautical almanac office which has been there for, I guess, 200 years, helping people in boats not to get lost. Long before we had GPS or radio or anything like that, they had to know how to find their way with the stars and the sun and the moon. All right, here you're going to be in Oregon. What can you do to make it a good time? This is where you're going to be, somewhere in that band, I hope. Now, you'll notice that Cottage Grove is down here. We're not in that band. And it goes all the way across Oregon. You can be anywhere in there. Let's go a little further. The thing I say at the bottom is try to get to the eclipse site a little bit early. Don't show up just at the last minute. You might not be able to find a place to park or stop or anything like that. This is going to be a popular event. You've heard about that, right? Okay. a little bit of a close-up here. This shows that if you're on the center line, the time you'll have in totality, that means the total darkness of the sun, will be about 2 minutes. If you're to the side of that, a little bit, it's fine. It doesn't make hardly any difference. If you go down to Corvallis or up to Salem, you still get about 1 minute and 45 seconds. And if you go down to the edge, though, at the edge of the stripe, then the time goes down to 0 when you get here. Okay? In fact, we're out of that down here at Cottage Grove, so only 98.5% of the sun will be covered in Cottage Grove. 98.5% will look like a very thin sliver, but there's so much light from the sun that that will still be 1,000 times as bright as the full moon, because the sun is so much brighter than the full moon. When you use eclipse glasses, which I'll show you in a moment, that cuts the sun's brightness down by 100,000, and it makes the sun look only as bright as the full moon, and that's perfectly fine to look at. Okay.
So you wouldn't see that perfect circle on the sun?
When you have a partial eclipse, you don't completely cover the sun. There'll be a little sliver, like a crescent, okay? Now, these are the times that the total eclipse will last for just about every place in Oregon. If you happen to be wanting to go to one of those, we can come back here later and check on that. Oops. So, a few very important things on this chart. Even if there's a tiny little bit of sun showing, like in Cottage Grove, there will be a tiny bit, 1.5% of the sun. That will spoil the most important parts of the eclipse. You will not be able to see the corona, you will not be able to see the stars, you will not be able to see the planets. Okay? You still might have a few birds do some things, but mostly you're not going to be able to see the most important things that we like in a total eclipse. So please try to get into that path. And I will tell you that if I were you, I would try to get into the southern part of the path rather than the northern part of the path, because what do we have north of the path? Portland, and there'll be a lot more people coming from the north than from the south. All right? Okay. It says here about binoculars. Someone asked a question about binoculars. When it's a total eclipse, when the sun is totally covered, sure, you can use binoculars or a telescope. You might see much more detail around the sun that way. Make sure you're not looking at the sun, though, 2 seconds before it's going to come back out again, because that could zap your eyes. Don't do that. Make sure that when you have binoculars looking at it, that you're doing it with somebody telling you to stop, okay, at time. Yes? It's not impossible to look at the sun if you don't mind your eyes being burned. Say that again? She asks if it's a natural instinct to close your eyes. It is, and that can help save you, but if you have binoculars, that magnifies the amount of light hitting your eyes by a factor of 100, and that makes it very dangerous to be looking at the sun with binoculars, okay? Yes?
What about peripheral vision?
Peripheral vision, you don't want to worry about, yeah. Yeah, don't take a chance. That's what it says here. So anyway, as I said here, the special glasses that you have, here are a couple examples of them. They block 99.999% of the light. And this is an interesting thing on the bottom here. It says that 4,800 library organizations across the United States will be giving away free 2 million glasses as a part of an outreach project. So this is what the glasses can look like. There are actually 2 different kinds that are fairly inexpensive. The kind you see here makes the sun look a little bit orange. It's a very nice, pleasant color. I looked at it today. The other kind, which is more reflective, has mylar reflection. This makes the sun look more white in color. Depends what you can choose it for the color. These glasses are available for $2 or less almost everywhere. They don't cost much, and they'll save your eyes, which is important. Now, it is also possible, if you want to be a little fancy, to project, either with a camera or the telescope or binoculars, what the sun's going to look like, project it on a screen. You notice that where the binoculars are, there is also a board, and that stops extra light from getting to the screen. So if you want to, you can try this before the eclipse too. You can project the sun if you want to look at that. But my personal advice is not to bother with stuff like that. All right, here's the stuff that everybody's scared of. Things to watch out during the eclipse. Across the country, 12 million people live right in the band where the total eclipse will occur. But within 1 day's drive of that stripe, 225 million Americans are living right now. Okay. Some people say the population may more than double. I'm afraid it may more than triple or quadruple. They're coming from other places too. But most people who come here will not be coming from Australia. They'll be coming from Portland or Seattle or California. Okay, so it has been said that this will be one of the worst traffic days, if not the worst traffic day in American history. Why? Because everybody's going to the same place. All right? Think about this. Gasoline. You better get some gasoline beforehand. I suspect if anybody is running out of gas, there'll be long lines at gas stations, okay? Bathrooms may be hard to find if there are lots of people. If you're in your car, we strongly suggest you take along extra water, extra food, maps, because I'll tell you why maps in a moment, and if you need any medicines. You may get stuck somewhere for a while. All right, why do you need maps? Anyone guess? Because if you're used to depending on your smartphone or anything else, it may not be working too much. With all those people around, the traffic on the internet and on Wi-Fi and cell phone towers and all that may be severe. Yes, okay. All right, when it gets real dark, guess what you should do? Turn on your lights, just like in a tunnel, right? Okay. Don't get in accidents. Guess what's going to happen if there's an accident and a traffic jam together? It's going to be horrible, right? Anyway, the state is responding to all of this, as is the federal government. There are going to be lots of extra response teams and emergency equipment out there. Now, here's the most important point about traffic. When is the worst traffic going to be? Just after it's over. Because that's when everybody says, oh, I've seen the eclipse, now I can go home. There'll be lots of people coming early to get a place at different times, but after the eclipse, if everybody leaves, it's going to be the worst. So I suggest you stay where you are for maybe half an hour, have lunch, take it easy. Don't try to get home right away. All right, I did a little calculation here. I just summarized for you this calculation. I assumed that there are about 4 lanes northbound in Lane County that will take us up toward Corvallis and places where we might want to go. That we might have 80 cars per lane per mile if you have a separation of maybe 60 feet between cars. That we have to travel about 60 miles or so. Anyway, put all this together. The capacity of the roads, okay, in Lane County and going up to Corvallis and Salem, the capacity of the roads is about 320,000 people. I'm not saying cars, just I'm assuming three people per car. So remember, that's about as many people as we have here. Not counting people from California, not counting people from Portland or other places or Australia. The roads could be entirely full. Now, of course, they can go slower, the cars can be closer together, then you get more people on. That's called bumper-to-bumper traffic, right? So I am recommending, and I plan to travel before 6 in the morning, just to try to avoid all that. And there's another reason. Here's some estimate of the expected crowds. Somebody did. I have no reason to believe in this person, but he gave some reasons. We might have 500,000 people moving to Albany. Interstate 5 is, of course, the most popular route. I would suggest staying off Interstate 5 if you're not going to be very early. But all these small towns are going to have their populations go up probably by factors of 10. Now, maybe you'll go somewhere in advance. That's a good idea. Get there for the night before or a few days before. There are lots of festivals happening. And the crazy thing is that some people think eclipses are really, really incredible events. And they want to celebrate them the same way that the ancients celebrated in Stonehenge. Okay? So in eastern Oregon, there's an event. Which one is that? At the Ochoco National Forest, where they're having over 300 performance acts. 300 performance acts are going to be there for several days. There's a big festival in Madras, and almost every place that can make money on this eclipse is going to try to do it, okay? So here's a list of places that you can find a lot of other people. Extremely important. Hello? Extremely important. The weather. In August, it's usually pretty good weather in August. But we sometimes have marine layer of clouds coming in if you're too close to the coast. So be careful about that. If it's forecast to be that way, you may want to get up real early and head across the mountains. So think about that. That's why I said I don't know where I'm going yet. You might want to have a plan A, a plan B, and a plan C as to where you can go. Because you would prefer not to be under a cloud. Okay, I have a few more things to talk about here. Some of these things are my own personal experiences, and I hope you'll indulge me in that a little. I hope they'll be interesting to you. But let's talk about some of the historical eclipses. We know that there have been eclipses ever since humans have been on Earth, and they have recorded some of those. There's some stones in Ireland where it looks like they were talking about an eclipse back in over 3000 BCE, so over 5,000 years ago. And in China, there's a record of an eclipse going back over 4,000 years. The Babylonians actually observed enough eclipses with their long civilization that they could predict lunar eclipses and later solar eclipses. They used a thing called the Saros cycle, which is about 18 years, to try to forecast eclipses. William the Conqueror, who came in and took over England, he had a son who died almost at the same time as an eclipse in 1133. And a chronicler of that time said that the hideous darkness agitated the hearts of men. A lot of people get afraid when they see an eclipse. Are you going to be afraid? You're afraid of the traffic, at least? Yes? Yes?
I saw the 1998 eclipse, and my lizard brain was warring with my cerebellum. My lizard brain was yelling, run, 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 even though it was on a ship. And my other brain was going, oh, it's just a big shadow, don't worry about it. The other brain's going, run, run.
So Ona said that her lizard brain was telling her to run during the eclipse that she saw. Okay, it can be a little scary if you don't know what's going on. One of the advantages of science is that we can predict things that might scare us, and then they don't scare us quite as much. Okay, anyway, because of that eclipse in 1133, there was a struggle. Everybody was so upset that they decided they needed to have a civil war to find out how they were going to deal with it. And in 1919, a very important solar eclipse, when you could see the stars around the sun, astronomers measured those very carefully, and that was the first proof of Einstein's general theory of relativity, and that made him a very famous man in the world due to an eclipse. Now, we will not always have total eclipses on Earth. They will go away because the moon is not always going to go around at the same distance from the Earth. As the moon makes tides on the Earth, those tides and the Earth's rotation tend to create a certain amount of friction. That's called tidal friction. And that slows the Earth down so the days get longer, and not long enough so you can sleep more, but anyway, they get longer a little bit. And the moon has to take up some of that lost angular momentum and drift farther away. Right now, the moon is drifting away at the rapid speed of 1.5 inches per year. Okay, it's getting farther away. But that means that over the next 500 million years, the moon will finally go so far away that that little cone that makes the black spot, that makes a total eclipse possible, that will not touch the Earth at all. And 500 million years from now and later, there will be no more total eclipses from the moon. So we're pretty lucky to live now when we still have total eclipses. All right. Take a look at this lunar eclipse. According to people who think we have a flat Earth and don't really pay much attention to science, they might think that the Earth is on the back of a turtle and then elephants. Okay? That was an old idea for the Earth being a flat Earth carried on the back of elephants on the back of a turtle. And that's what a lunar eclipse would look like if that were the case. Okay? But we try to realize that if you look at the actual lunar eclipse, it's a round thing that can cover the whole moon. And I like to say that we need to respect science a little bit. I say that as a scientist, but I wish everybody would, okay? Thank you. The predictions I'm giving you, I would be happy to bet anybody any amount of money there will be an eclipse on August 21st. I don't have any doubt of that. I'm not sure about a lot of other things, but that I'm very sure of. So too many people dismiss science in many areas, and that's due to their fears of things. They're not sure why that lightning came down, so they might believe that somebody was, a god throwing lightning bolts down upon them. They might have poor education. That's a sad thing. Politics sometimes makes people want to deny science for various reasons. And unfortunately, some people think they can make more money if they tell you that the science isn't true. So be careful about those kind of things. I'll just say a couple words about the sun, which is getting eclipsed. For a little while, we're not going to have the light from the sun. What does that do? It makes it colder here. The sun is necessary to us. All right, the sun gives us life, the sun gives us warmth, and the sun, of course, gives us energy. How many of you have any involvement with solar energy at all? Anybody? Just a few people here? Okay, you all have involvement with solar energy. You would be frozen to death if you didn't have any involvement with solar energy. All right, and as I said on the questions, the trivia questions, the sun is putting out a total amount of energy of 100 billion 1 megaton hydrogen bombs every second. That's like every single person on Earth having in your hand a little clicker that you could click 14 times a second if your thumbs were really good. 14 times a second. If everybody on Earth was doing that 14 times a second and every clicker made a hydrogen bomb like that go off, that would be the output of the sun. Okay, it's a tremendous amount of energy, okay? But the sun has so much mass, over 300,000 times the mass of the Earth, that even though it's producing that much energy, converting hydrogen into helium and turning 5 million tons of mass into pure energy every second, it still has enough mass to do that for 10 billion years. So we have a good sun. You should be happy about our sun. Maybe we should worship it. I think I'm going to call it Apollo or something like that. Oh, sorry. Okay, and as you know, there are people who argue about climate change, global warming and such, but Earth's surface temperature has clearly risen by almost a couple degrees in the past 100 years, and that's due to the increasing carbon dioxide, primarily from burning fossil fuels that we have put into the atmosphere. There's no question of that. Astronomers understand that. I did a lot of work with infrared spectroscopy and studying stars and stuff. People who study the climate know that. And the main thing I wanted to point out here, as it was on the trivia quiz, is that the changes in the sun have only less than 0.1% impact on the energy coming to the Earth, whether it's sunspots or no sunspots or solar cycles or anything. That's not the reason that the Earth is getting warmer. The sun is much steadier than that. And the sun is going to have almost exactly the same energy coming out for millions and millions of years in the future, okay? So it's really the stuff we're doing here on Earth that we have to pay attention to. And don't let anybody tell you that, oh, you don't have to worry about that, because our grandchildren and great-grandchildren may. And the people who worry about various bacteria and insects and other things moving around because of changes in the climate, or they worry about your food supply, they still have to worry about that. Anyway, I like to quote Rachel Carson here, who probably got more people aware of the environment than anyone else in history. The more clearly we can focus our attention on the wonders and realities of the universe about us, the less taste we shall have for destruction. So we need science to help us. And that's another reason to support the Coast Fork Willamette Watershed Council, because they're using science.
And stop clear cuts.
Okay. Here is a couple things that I worked on a little bit. You probably know that there are tides. Sometimes there's low tide and high tide, especially near the ocean shore. And that's due to the moon primarily. The moon is much, much smaller than the sun, 27 million times less mass than the sun. But it's 400 times closer to us. And that makes the moon's effect on the tides more than twice as important as the sun's effect. Still, though, when the moon and the sun are lined up, like they are in eclipses and in general a new moon and full moon, new moon is when the moon is between us and the sun, right? And full moon is when it's on the other side where we can see it. Remember that? Okay. When it's new moon or full moon, that lining up makes the tides the strongest. Those are called the spring tides, okay? And we have the strongest tides like that twice a month. Now, that alignment has an impact on my life, okay? When I was much younger, in 1971, I felt a shaking when I was living in an apartment in Venice Beach, California, at 6:01 in the morning. I leapt out of my bed, and I knew that I should stand in the doorway because there was an earthquake. But I was looking out the window while I was standing there, and I saw the full moon about to set. Okay? Could I have seen the new moon? No, you never see the new moon. That's the no moon. I saw the full moon about to set. I also happened to know, since I was an astronomy graduate student at the time, that there was going to be a lunar eclipse that very night. So that was really lined up perfectly, okay? And I began to think about that. I thought about it for quite a few years, and 12 years later, I finally published something about that, because I knew as a child that I had been shaken out of bed by the 1952 earthquake in Tehachapi, Southern California. I knew that in 1933 there had been an earthquake in Long Beach, California, which killed quite a few people and made them make a law in Los Angeles that you couldn't build any building taller than 13 stories high because they were too afraid of earthquakes. And they made one exception, that was for the City Hall, which they built really strong. So I knew about those, and those were 19-year intervals before 1971. Later, while I was studying all this, I found that there had been the biggest earthquake ever in Southern California in 1857, right on the San Andreas Fault, and that fit the 19-year cycle perfectly, okay? Let me tell you why that is, I think. Not everybody agrees with me, but I published the paper in 1983, which claimed that when you have the moon and the sun on the horizon, that's at 6 in the morning or 6 in the evening, right? That's when they'll be on the horizon. You don't get the sun on the horizon at midnight, okay? That they tend to, the tidal effect they have stretches the water and the earth sideways, east and west. It just so happens that the boundary plate between the boundary line between the North American plate and the Pacific plate, those plate tectonics things you may have heard about, they go in this direction in Southern California. And the Pacific plate is moving toward the northwest relative to the North American plate. So if they're pulling out this way, there's a component of that pull this way, and a component that way, and a component this way, and a component that way. We can divide the pulls in that direction. The pull here tends to separate the San Andreas Fault a little bit, and the pull here tends to pull that Pacific plate in the direction you want it to go to make an earthquake if you like earthquakes, okay? All right. So those kind of things make earthquakes possibly a little bit more possible. They trigger the earthquakes possible. And also, I was very surprised to find that this 19-year cycle, actually 18.6 years, was the cycle of the moon's orbit, which is tilted, wobbling around, rotating every 18.6 years. That's called something weird you don't want to know about. But anyway, that cycle brought the moon to its northernmost position every 18.6 years, and that happened to be within a year or two of all these earthquakes. So I thought there's something going on here, and I published it, and I predicted that there would be a pretty good chance of earthquakes around November 1987, 4 years later, and big earthquakes. And there were 3 magnitude 6 earthquakes in the Los Angeles area in October and November of that year. So that's when I got on TV, and everyone wanted to see what was happening. But it didn't predict all the earthquakes, just some of them, okay?
And how about 20 years later?
20 years later, there was no big earthquake because there was another huge earthquake, and this is part of the theory, that sort of disrupted everything for a while. Just like after that big 1857 earthquake, there were no earthquakes for about 30 years. But I expect the cycle is going to come back again in another 30 years or so.
And you've looked at that a lot, the whole ring of fire?
Just where the orientation of the earthquakes is right. This is a lot of people have investigated the moon and the sun and earthquakes and stuff, and they haven't found anything because it has to be just the right geographical angle for that pull to help. Because if it's the other way, the pull will hurt. Okay. All right. All right. So here I want to talk just a little bit about SETI. That's the Search for Extraterrestrial Intelligence, another hobby of mine. So who's going to ever send us a signal if we want to look for one? Probably somebody out there who knows that we're here, right? Does that make sense? They're more likely to send us a signal if they know we're here. And they have to be a fairly young civilization, maybe a little more advanced than us, because I feel that if they were more than 40 million years more advanced than we were, by that time they would have gotten here in a spaceship, something like this, one that I've developed a little bit. So I think that we have a window here where it's not the most advanced civilizations in the galaxy, because they would already have been here. They haven't come here. Have you seen any UFOs? Maybe. I'm not sure they've been here yet. But I think that they need to know about us. Now, one way that it's easy to see if there's a planet around a star, you may have heard about this in the news, is if the planet is doing something like an eclipse. It's called a transit, and it doesn't cover the whole star, but it makes the star a little bit darker. Okay? And when you see the light go down as the planet goes in front of the star, the light from the star goes down a little bit. That tells us sometimes that there's a planet there. Okay? That's important. And we have a spacecraft that can measure the brightness change of a star to within better than 1 part in 10,000. So they can tell if a small planet is going in front of the star. That Kepler spacecraft has found thousands of planets already. All right. Here we have in our own solar system, I don't know if you saw this 5 years ago, but the planet Venus went in front of the sun as seen from Earth. This is about what it would look like if Earth went in front of the sun as seen from somebody many light years away. It would make the sun look darker, right? So I feel that there's a good chance that the first aliens to know about us will be someone who sees this kind of darkening of our star due to us going by. Now, here we have a little picture of our galaxy, a diagram, and this is the orbit of the Earth around the sun projected out in space. So only if stars and planets are located in this plane will they be able to see us go in front of the sun. You understand that? Right. Like I can see some of you block each other's heads, but if I was up there in the ceiling, I wouldn't see anybody blocking a head, right? That's the same kind of thing. So they have to be in that plane, and that's shown in the bottom here. They have to be in a narrow region here where they'll see the Earth blocking the sun, a narrow half-degree stripe there. And that's because the sun looks half a degree wide as we see it. It turns out that if you do all these analyses, they have about 50 times better chance of finding us this way than by all the other ways we think they can use. And that's why I think that's how we are going to be discovered by another group. And there's another point there. If we're going to be discovered by them, that means that they know about us. They might be looking at us, right? And therefore, they would be the best locations to send a message to, because they'd be noticing us anyway. All right. So the first question to be answered about extraterrestrial intelligence that we contact is, what's your sign? Because they will be in this plane of our orbit, the same plane the sun goes through in the sky that's called the ecliptic, or as you've probably heard it more often, the zodiac, okay? Where all the constellations are that the sun goes through. Okay, finally we'll talk a little bit about Grokking, but not quite yet. I want to tell you one more thing about astronomy. You know that astronomy finds things in the universe and finds the connections between them and how they work. The word star in Old English, stara, was almost the same word they used for steering, your steering wheel, because they knew that stars helped them figure out where they had to go. They didn't have street lights, and they didn't have compasses, and they didn't have GPS, certainly, but the people steered by the stars, especially if they're out in the ocean. And of course, stars are also valuable for agriculture, right? Most people say that astronomy is the second oldest science. Agriculture is the oldest, figuring out how to grow our food. But astronomy helps agriculture. The Egyptians used the positions of the stars and the planets and the sun to figure out when to put their seeds in the ground and when to harvest things, partly. Okay, so anyway, knowing about eclipses and other parts of astronomy is a key factor in applying the laws of nature, and helps us, helps the whole universe, because we're part of the universe, become aware of what it's doing and conscious of its future. Now, the day July 20th, 1976 was a big day for me. I was at Jet Propulsion Laboratory to see the first photograph come down to the Earth from Mars, from the surface of Mars. We had never landed on Mars. We didn't know if there were Martians. We didn't know anything about life on Mars at that time. And I was there, and I saw this picture, the very first picture come from the surface of Mars, and I was standing at the television monitor next to just one person, and that was Carl Sagan, who was my teacher there. And we were watching the first picture from Mars. He was a very enthusiastic person who studied the planets, and so was I, and we were very anxious to see that first picture. Now, he became famous later, but nobody knew about him much at that time except me. And then I went, earlier that day, I'd gone into the cafeteria at JPL, and I saw a man sitting all by himself there, and that was Gene Roddenberry, the guy who created Star Trek. And many people pay a lot of attention to Star Trek, and they think about the universe based on going where no person has ever gone before, right? The one person I couldn't see who was there for that event, because he was in the VIP room where I was not allowed, was a man named Robert Heinlein. And Robert Heinlein was an author. I had read some of his books when I was very young, nice science fiction books like Red Planet Mars. And he was there talking to the press, he was holding court, sort of. But he was the one who wrote Stranger in a Strange Land, where the word grok first appeared. He invented the word grok. And the word grok he defined as a Martian word which meant to drink, but also to really understand something thoroughly and completely, to drink it all in, to be one with something, to have empathy for what you understand and to love it. That means to grok. And I'd like you to grok the eclipse that we're going to have. My personal advice for how to grok the eclipse. You don't have to do what I say, but this is what I would suggest. Don't talk too much. communicate a little bit with the people around you, but mostly try just to experience it yourself. Try to rely on your own perceptions. If you want to use binoculars during the time it's dark, that's fine. If you want to use eclipse glasses, that's fine. But mostly try to do that. Don't spend all your time setting up a telescope and playing with various equipment and cameras and so on. Try to pay attention. There will be people who have lots of better equipment than you probably, who will take fantastic pictures, and you can see that later if you want to. You don't have to record it yourself. Okay? And be there in the moment. As Heinlein said about in one of his characters in his books, he was in no hurry. He grokked that eternity and the ever beautifully changing now were identical. So that's sort of what grokking. I want you to have a connection with that eclipse. And there's a reason for that. During totality, that means that a straight line will pass through the deep center of the sun, through the center of the moon, and through Oregon, and through you. You will be entirely lined up with those things. Okay? You will experience on the eclipse day something that you should feel connects you with the universe. It joins you together with it. So helping you feel our universe, remember that you don't just live your life on a screen. You're right there. You have lots of rhythms, days, months, years, 18-year cycles, 375 years between total solar eclipses. I discovered a comet that's going to come back in 180,000 years. I'm connected to that. 200 million years it'll take us to go around our galaxy. We have lots of cycles that we're all part of. You can have a festival to celebrate some of those things, the way the ancients at Stonehenge, the Druids, and people in Madras and other places are going to be celebrating. I suspect there will be some drugs involved too. You can celebrate all these special moments. You can dance and be happy. That's great. But I also think that frenzied excitement may not be the best way to have a profoundly meaningful understanding and feeling of the universe. So I would say find a good spot and just let all your senses take it in. It's going to be a short time, 2 minutes of totality, followed by possible disappointment. It was over so quickly. And as Ona said, she might have been a little scared when the sun finally comes back and it's a little bit lighter. You can see who's around you. You may feel a sense of relief. It wasn't the end of everything after all. You've just come out of a dream in the dark. So I encourage you to just experience that reality. And this evening when it gets dark, if it's not cloudy, I hope, don't forget to look for the crescent moon, which I can confidently predict will be up there, close to the sun. And thank you for listening, and ask any questions you have. Thank you. Yes, you have a question. The different crescent moons, yes.
In Hawaii, if you see the crescent moon, it looks like a hat, or it's just your
Okay. In Hawaii, the crescent moon looks more horizontal and less vertical. That's because when the sun sets in Hawaii, it almost always sets close to due east and due west. Here, the sun often sets closer to the north in the summertime, closer to the south in the wintertime, and that angle tilts the crescent moon up. Remember that the curved part of the crescent always points toward the sun. See a different angle, yes. Any other questions? Yes. Okay. That's feedback, okay. If you want to use a camera for the eclipse, that's fine. It's going to be very small up there unless you have a telephoto lens or a telescope it's attached to. You might be able to see the corona. But again, I emphasize that whatever you say, that's my picture, I took it, that's great. But it won't be anything like what the professional photographers and astronomers will be taking a picture of. Yes? There is often a lunar eclipse close to a solar eclipse. This particular time, though, I'm not aware of it. If it's there, I forgot to learn about it. Okay. A lunar eclipse, you may remember, I don't know if I said this right, When you have a lunar eclipse, that's when the moon is on the other side of the Earth from the sun, so we can see the moon there. And it's often sort of reddish or brown in color because the light from the sun goes through the Earth's atmosphere like at sunset and sunrise, and the red light gets through, just like you see a red sunset. That makes the moon a little bit red too. This will be a solar eclipse, and that's the most spectacular one, though. Okay. I'm sorry? Monday, August 21st. Oh, there is a lunar eclipse? Okay. Is it visible from here? Sometimes the lunar eclipse is only visible on one side of the world. It's on the other. That's why I didn't remember it. Okay. We cannot see that lunar eclipse from Oregon. Okay. Yes.
I'll be camping just south of the total eclipse zone. How far into the zone would he get to experience darkness, twilight?
All right. If you want to know how far into the total eclipse zone you have to get to experience darkness, all you have to do is be a tiny bit into it. But if you're just a tiny bit into the zone, the eclipse will only last a few seconds. It lasts longer as you get toward the center of. If you're within about 25 miles of the center line, you'll have a pretty long eclipse, over a minute or so. Any other questions? Well, thank you all very much. I hope you stay. I hope you all stay safe and have a great time, and maybe we can get together after the eclipse and talk about your experiences.